to demonstrate their latest production of robots. So please follow me to check out the latest inventions in this industry. I'm now in this hall A, and this is the combination of robots plus logistics. We have a robotic arm here, and he's about to play ping pong. We have just launched this robotic arm, so there are some errors. And maybe you are wondering why we have to make this design, because by this simulation, we would like to test to see the robotic arm can also follow the movements of a real person's arm. Because when you want to play ping pong, you have to know how to send orders to all these different joints of your arm. If you put up too much effort, then the ping pong ball would just fly away. And if you don't pay too much attention, then you cannot make continuous movement. If the ping pong ball can be played in this way in a continuous manner, then it means that we have succeeded in the design of the robotic arm. So we have an expert here to give us more explanations. This time, this is an example of demonstration of industrial robotic arm to play the ping pong ball. This is also a process of automatic learning. For the first time in this industry, we have this robotic arm controlled by the artificial intelligence. And this robotic arm can complete the learning by itself. In the beginning of the practice, it cannot play well with the ping pong ball. However, every time with the practice and with the trial, the robotic arm can correct its own behavior and performance, and we can keep going on and on with this playing of ping pong ball for 1 or even 2 hours every day. And today we have many scenarios of the application of robotic arm, but in many of the scenarios, we cannot use the robotic arms to replace a real man's hand, because usually we have to be really focused and we have to accomplish those very complicated movements and practices. But today, gradually, we can train our robotic arm. It's just like we train a worker in the factory. We can train the robotic arm. Today, with only one set of the robotic arm or multiple sets of the robotic arms, we can make the handling of objects as well as the other movements much easier and more feasible for the robotic arms. We also have other examples to showcase to our audience to see how we can use the robotic arms to replace human effort. And maybe for the other set of examples, there are higher requirements for the precision of the movement. With this set of machine, you can do the design and planification of the movement trajectory of 3 different robotic arms, and all those robotic arms can stay in very high precision during the movement. For example, in industrial scenarios, sometimes we would like to put different machines together, different robots together. Like for the diesel vehicles, there is a pipe for the evacuation of the gas, and that pipe has been composed of different parts, up to 3 to 4 parts. And when you do the welding of different parts to have the final tube, then you have to do the welding in the same time. That's why we have to enable the robotic arm all at once. And over there, even a set of machine with 4 different robotic arms. That is also for the welding. Yes, it's the point-to-point welding. So maybe we can make a detour to have a closer look at that set of machine. So first of all, it's a question of speed, and the second is a question of precision. For this one, it's quite huge in its size. And what about the strength level? First of all, when it's in very heavy load, it's quite challenging for this solution. We would like to showcase, first of all, the big size model, and the second, it's a station of work for the point-to-point welding. This is a part from the vehicle. We have put different shapes of parts together in order to do the welding. And here we have applied a large scale of machineries, the robotic arms, to do the simultaneous welding of different parts. Maybe we can give you some more extra information. Now we are just doing the simulation of the welding because we are still in an exhibition hall. We cannot do it in a real way. Thank you very much. So let's continue with our trip in the exhibition center. We have just visited different sets of robotic arm models. We have general robots and also scenario-based robots. Just now, those are scenario-based robots. On the one hand, we would like to showcase how practical they are, and on the other hand, we would like to show you how precise they could be and how similar they could be in comparison to the human body movements, like the simulation of the human joints with the robotic arm. As far as I know, we have the robots of the joint movement of multiple joints. There are different conjunctures of the robotic arms, different points of connections. And this is a robot for the coffee making. Last month, I've also made a similar report about that. But this one is quite special because inside we have inserted a machine learning system. So these machines, they could learn from the coffee masters to do different patterns with the latte. And here we also have espresso. We have the flat white options, so different options for coffee, and they can also do the patterning. And what about this one? From the knowledge that I've collected, among the 60 robots demonstrated this time, this one is quite capable of grabbing things, and is also very flexible in its movement. And when it's grabbing the other objects, it can be very gentle towards the object. So it's a kind of gentleman-like robotic arm. Once again, I'd like to tell you that I'm now visiting the Hall A. It's more like scenario-based and industrial-based robots. And for the B hall, it's more related to the old age care and medication. We also have the E hall, where we can find the specialized robots to fight against the explosions, and also the firefighting robots that can really replace the human efforts in our daily jobs. And this is a robot in collaboration. For example, now they are doing some showcasing. With one robotic arm, we can grasp the plate, and there is also the surveillance camera. With that, we can know what kind of object we have grasped. So could you please give us a demonstration, or I myself can have a try? So you can say hi to this robot. His name is Xiaoduo. You can hold the plate, and later on you can hand it to the robot, and it can be detected. Hello, Xiaoduo. Because we are in a very noisy environment, so you can say that again. And now the machine has started the movement. Because previously we have already set the scope, so I have to get nearer to this robotic arm. And now the robot is asking what I would like to have. I would like to have banana. I would like to have a banana. Now on the screen, we can have the transcript about our dialogue. And immediately the machine has detected what I wanted. So now in this exhibition hall, we have some challenging factors, for example, the noise in the nearby environment and also the internet speed is also limiting the normal performance of our robotic arm. And now the robotic arm is holding up the banana, and to hold up the things, to grab the things, it's always a big task, a big challenge to our robotic arms, because the machine has to know to what extent the effort should be. If it's too strong, then the object would be crashed. And today, what kind of scenarios of application for these robotic arms in industries or in daily life? Today is mostly in the semiconductor production, vehicle production scenarios, and it can also be used for the welding, for the treatment of the screws, etc. In the service sector, we can also use the robotic arm to replace some of the human effort, for example, to make the coffee, to make instant noodles, and also to make the cocktail. And we believe that there will be millions of different scenarios where we can apply the robotic arms, and we are still on the way to explore more possibilities. And in our daily life, it's also a very useful assistance. For example, for people with disabilities, the robotic arms could immediately help to grab something from far away. And also with the computing technologies, we can also allow the robotic arms to accomplish more tasks. Today, we are using the framework of AI and also the voice recognition. We also have the image recognition enabled by the computer technologies. And over there, there's another coffee machine with the robots. And today we have witnessed different sets of the coffee machines, but only the previous one can do the latte art. And this one has been applied in the industrial manufacturing. And we can also do the grocery scanning. And if you would like to set the sticky label on the surface of the box, of the package box, then you can also use the robotic arm, and it's zero error. Previously, we have visited some stands for the robotic arms, and especially in the heavy industry, is widely applied and used. And this time for our 2024 World Robots Conference, we have also demonstrated some separate parts. For example, the reduction drive. We have to use the reduction drive so as to moderate the movement flexibility as well as the rate of movement of the robotic arms. Because when the robotic arms approach the object to grab, then it has to slow down the speed. And here we can see another example of the robotic arm. This is a product of the Institute of Automation of the China Academy of Sciences, and we have a personnel here to give us some explanations. Good afternoon, dear viewers online. We have this robotic arm, which is called Cassia Hand, and this is a product of Institute of Automation of our China Academy of Sciences. We have inserted the software packages of the AI, and it's also accompanied by some latest invention of the hardware. I've noticed that previously one of your personnel have put up a glove specially made, and then this robotic hand can also simulate the movements of a person's hand. So could you please demonstrate this one again for our audience? Yes, of course. Thank you very much for giving this opportunity. I've noticed that this is a big size. It's used in specialized scenario. We need human effort to monitor the movement of this. For example, in the removal of the mining of some explosions, it can help us to stay safe, and we use the robotic arms to replace the human effort. We also need some time for the matching. As we can see, our personnel there is getting ready. She's on gloves, and the gloves are connected to the robotic hands and arms. And later on, we do the matching of the movement and also the recognition of the signals. And now she's moving the fingers and hand. And here you can see our robotic arms. They are doing exactly the same movements. For example, when there are some complex scenarios in some difficult and dangerous scenarios, if you put a human worker there, it's very dangerous for the worker. But now we have this new opportunity, and this is a new possibility brought to us by the robotic arms and hands. We just put on the gloves, which are connected to these robotic arms, so we can stay on the backstage. And what is the current stage of researches in your group? We are studying the packages of the software and how we can combine the hardware and the software together. And we are also doing the simulation applications of these robotic arms to make sure that those robotic arms could approach the function of a real person's hand. And we can also use it in the service industry. For example, you have this flexible hand, and the flexible hand can use the mop to do some mopping, so we can replace the human effort in a restaurant during the cleaning moment. And what about the flexibility? We call it flexible hand, the cashier hand. And this cashier hand has 7 different flexibility with the models, and also 15 flexibility levels with the joints. For the flexibility levels is to control the scope of movement of the fingers and also the joints, so that the robotic arms can stretch and hold back. For the robotic arm and also the robotic hand, we have different axes of movement. For the robotic hand, it's one very important part of the whole robot industry. We humans, we know how to use the tools, but for the robots to use the tools, one condition is to enable the robots to have flexible hands. If today we can make sure that the hands of the robots are flexible enough, then it's quite probable that the robots can place the human efforts and can free human beings up in the difficult jobs. And today we have walked you through the stands of the robotic arms, the coffee making robots. So that is about some introduction to some of the stands of the A hall. But today I didn't walk you through all the A halls. Maybe I have just covered half of them. Now I'd like to give the floor to my colleague to see what other new possibilities brought to us thanks to the combination of robots and the healthcare industry. Dear viewers of CCTV News, my name is Yan Jiayi. I'm now in a permanent site for 2024 World Robot Conference in Beijing Etrong International Exhibition and Convention Center. And now I'm in a different hall where we can find a demonstration of the specialized robots, and those robots can go anywhere we want them to be, and how they can be closely connected to our daily life, and what is the supporting sciences behind all those products. So please follow me. I'll walk you through all those stands. For example, here you can see some rail framework, the rail systems. This is one model of robots for demonstration, and we would like to find out the explanations about this one. So I have invited a guest. This is Mr. Chang. And this one is moving according to the rail system. So could you please share with us more details about it? It's used in the mining system and it's anti-explosion. It's used underground. And in the mining field, this machinery or this robot is placing some patrolling forces. So it's doing the checks, examinations of the sites. It's carrying a camera with it, and the camera is replacing a human eye. Apart from that, we also have infrared detector to capture the changes of temperature. And there is also a sensor to replace a human nose to see if there's superior level of the gas to see if there is the leaking gas problem. And you can also collect the sounds from underground. You can do the recording and collection of voices and sounds from underground. So actually do you mean that this robot can place 100% human efforts underground? For example, it can smell for us, it can look around for us. So we are freed up from the dangerous environment from underground. Yes, first of all, it has helped to lower the risks, and it can also replace the human efforts in those difficult jobs. It can also do automatic analysis. In real time, the collected information will be sent back to the backstage, and it can do the detection of possible risks and problems. So on backstage, the system can do some calculation and analysis. If there is a problem detected, immediately there will be announcement sent to the workforce. And the machine system can also do the machine learning by itself. And apart from this rail system, do you have any other highlights to share with all of us? For the CITIC Group, we are a big pioneer in this industry, and we are one of the leaders. We have the products for the petrochemical, for the firefighting, and also for the mining fields. Previously, we have noticed this rail platform. We also have the Caterpillar and wheel-based platforms, so different kinds and shapes of the platforms. And based on these platforms, we can also develop the other models. So together, it's kind of countless combinations and synergy. And this one can be adapted to different road conditions. And it can replace the firefighters to do the firefighting job. So it must have the heat insulation function. Yes, of course, it cannot be burnt. And also for the Caterpillar, it's also anti-heat. It can resist up to 350 degrees of high heat, high temperature. And we have also applied the materials usually used in specialized industries. This one has its own climbing system and self-cooling system. When it's doing the firefighting job, it can also use its own techniques to cool the body down. For the firefighting functions, once it's connected to the water pump, it can cover a distance of, it can cover a height of 40 to 50 meters and also a distance of 100 meters. So with this machine, we can do the firefighting job for a 10-story building. So those are the real Iron Man in this field. For example, they can do the firefighting job, and they can also do the patrolling in the underground mining field. And they can also perform other jobs. What about that model of robots? What are the highlights? This one is for the execution of the jobs. It's used by the electricity centers. They can use the robotic hand to press on different buttons. So in this way, it can replace the human efforts in the patrolling. And this one can also turn the button. So today, it's very good news for our workers on site. because their workload has been significantly reduced. And just now we have checked out different models of robots that can be performing in various scenarios. For example, for firefighting, for patrolling underground. Meanwhile, we also have the other types of robots that can be used in agriculture. Now, what is the underlying logic for that? Now I've noticed this sensor for the transmission of the force. So you're the person in charge. What's your name, please? My name is Juan. So could you please give us explanation about the sensor? We have the 1 dimension up to 6 dimension sensors. Here on the wall, you can see the introduction to our products. And we have different size of the product. We have these different types of products with different levels of the torques. For example, the bigger one over there and smaller one here. Previously, you mentioned from 1 dimension to 6 dimension. Could you please give us more explanations? 1 dimension, it means 1 direction of the force. This is like the D1. For example, now I'm pressing downward, it's 1D. And also, the vibration can also be recorded. This is to show how sensible it is. When I'm pressing down, it's in the gravitational direction. And for the 6th dimension, it's not only in this direction, but also in the direction of the axis X, Y, and Z, plus with the turning of the 3 torques. In total, there are 6 dimensions or 6 directions. And have you applied the 6 dimension sensors here? Not yet, but maybe in the near future we can put one 6D sensor here, so we can do the polishing and grabbing with this part of the robotic arm. And immediately we can have the strength feedback thanks to the sensor. And there's a screen here. Could you please give us some demonstration? For example, now it's doing some checks. It's checking the lid and it's shooting some photos, and now it's moving towards another part of the machine to check another lid to see if it's correctly installed. What is the connection between this robotic arm and the strength sensor? Here, the robotic arm will just pull slightly the cables. And here, it's also grabbing the cables. We need to put a sensor here to know how big that effort has been. So it's also doing an X-ray job to see if everything's in the correct position. But we need to have a sensor so that the effort applied by the robotic arm could be better measured and calculated. When we put the sensor in the robotic arms could be smarter, more intelligent, and they would be closer to the human function. If we don't have a sensor here, then it's very hard for the robotic arm to decide how much effort it should make during the movement and the action. So let's continue with our trip here. We have very crowded hall and stand here. So let's go and check out what products are we displaying and as we can see here, we have a dance show. But it's a dance performance demonstrated by the robot dogs. So could you please give us more explanations? This is a dance show or the dance beats by the robotic dogs, the machine dogs. So good afternoon, Mr. Song. So you're in charge of the stand. Could you please give us more details? Yes, of course. Now you can see we have this machinery or the robot called Xiaotian. It's a kind of robotic dog. It's very small in size, but you can also keep it as a pet on the desk. In the near future, we think that this robotic dog can develop its own movements, their own expressions. Because it's enabled by the AI technology, it can also do the recognition of the emotions. And today, more and more people, they are developing the AI, and they are doing the AI plus applications. And for this robotic arm could be a very good platform. And it can assist people to continue with the development of AI-related applications. So for all the developers of AI technology, they can have their own type or their own version of this robotic dog with their own voices and a tailor-made solution. So everyone can have their DIY version of the pet on the desk. And I will explain to you how we can make the dogs so flexible. We have made several breakthroughs. First of all, for the head part of the robot, you can have a closer look at the head of the dog. We have put the cameras and the screen, as well as ear parts in this very small size of the head of the robotic dog. And later on, when we develop the next generation of technologies, you can just replace this head part with a new part with the new settings inside. We can use the head of the robot to control the movements of different parts of the body and also the rhythm of the movement. And you can also have a closer look at the joints. Of course, now in the market, we have similar projects, but we also have our highlights with the robotic dogs. We don't have to put the execution parts in different joints. Later on, we can also develop different versions of these robots. For example, not only dog-like, but also cat-like or human-like robots. And you have succeeded in guaranteeing the flexibility of the joints. And we can also see from the images of the movement, this robot has adopted the image of a dog. So in the future, you're about to promote different possibilities for the robotic animals. Yes, of course. This is our first model of the robotic animal. And through this model, we are trying to make the simulation of the animals in nature. Even in the future, we can use the robots to simulate the movements and also adopt the shapes of the insects. So this is a kind of evolution of the robotic species. And this robotic dog has the face, eyes, ears, and they can also perform some flexible reactions. So maybe I can invite my colleague to do a demonstration. Could you please tell me in the first place what kind of interactions that we can have with the dogs? Now it's a version of the dancing dogs, but for our to-see products, the robotic dogs can use the screen to detect who is the person in front of him. Is this person the master, or is a stranger, or is a friend of the master, etc.? Now I can see his eyes. And with this different eyesight, movements, facial expressions, it's also expressing its real emotions. It can behave just like a dog. And in China's tradition, the dogs are used to keep the courtyard safe. And today, with the robotic dogs, we can also do the same thing. It can send out a warning to the strangers. And when the dog has detected the intruders, immediately with the system, the robotic dog can send a message to the owner of the dog. And also, there are designs for the developers. Yes, of course. Previously, we have admired the dancing of the robotic dogs. And we can also prepare a list of orders by which even the beginners of the AI developing can learn how to make the robotic dogs move according to a preset rhythm. And here we believe that our philosophy is to see is to have. For the users, they don't need to do the complicated calculation and settings. We can just make some moderations of the time axis. Then in real life, the robotic dog can do the exact movement. So even for a small kid, if he knows how to use a mouse to control the movement of this robotic dog in our system, then in real life, the movement is designed. So that is why we are so convinced about the evolution of new species based on machineries. Thank you so much for the introduction. And it's a very good example of the combination of AI and robotic arms, as well as the cultural innovation. Thank you so much for your introduction. So just now we have appreciated the wonderful performance of the robotic dogs, and even for ordinary people, we can embed our innovative ideas into the robots. In front of me now, we have some stands of the separate parts of the robots. and it's used in education. And we can see many kids they are gathered here because those products, those robots, they are designed for the kids and for their education. And this is also a stand installed for their benefits. Good afternoon. This is a kind of product used for education to assist the education program for children. It's separate parts and it's not the assembly of the machines. If you give a manufacturer the finished product to the children, they don't have to learn anything else but the driving of the car. But here we only give them separate parts, all those small pieces. So the children, they have to learn from zero how to manufacture a car, how to put up all the separate parts together. And this is a very good way to mobilize all the kids because they cannot get the finished products in the first place. They have to learn from scratch and from zero. And they can also have their own design of the vehicle. You can do whatever you want. Because our parts can be put up in different ways, it gives flexibility to our children. If you don't like this solution of the manufacturing, then you can draw the other solutions. You can make the other drawings and the sketches. And you can also make some modifications based on the given solutions. If you are not satisfied with this kind of solution, then you can change it. You can change some of it, or you can change most of it. If you look at the automobile industry, you can find that the engineers from Western countries are more costly than the Chinese engineers because the Westerners, the Western engineers in the past, they could do a better job. That's why we also have to educate our children to reach to this height. And we have more than 3,000 separate parts. This is to give us many possibilities as possible to our kids. Whatever kinds of the separate parts you want, we can always find it out for you. If we don't have it for the moment, then we will just make it for you. So you just tell me what kind of separate parts you want. So these separate parts can really give the possibility to the children, and we are here to assist their design and assist the manufacturing. If you can give more choices of the separate parts to the children, then they can have a bigger room for design and building up of the vehicles. We also give them a modeling, a map to them. First of all, we use the computer to do the simulation. When we do the transformation of the separate parts, in theory and in real practices, there is always a small error. There's a small difference, and you have to know how to be adapted to a real product. And in real life, if you go to work in a factory, it's the same problem you're about to encounter. For example, you can be 100% perfect in the mapping, in the drawing, but after the production of the separate parts, you always find some little difference, and you have to know how to regulate the difference. Today, as you can see, the robotic arms or the robots, they are everywhere in our daily life, even in education. Just now, we have visited the stands that has proposed different types of separate parts of machines that will mobilize our children to be brave and crazy enough in imagination. And next one, I think is used for the Medicare. Good afternoon. We are with the CCTV. Could you please give us some details of this one? This is a huge robot. It's called Kangduo. It's used for the surgeries. And you also have the screen here. This is a screen for the 3D simulation. Usually, if you would like to have the 3D images, you have to put on specialized glasses. And when you go to the cinema, you also have to stay in distance from the screen of projection. And now, with only naked eyes, you can already see the 3D images. And the machine can also detect the angles of our eyesight. And this is the control panel for our doctors, for the surgeons. Good afternoon. We are with CCTV. Is it okay for us to have a check inside? Yes, of course. Just now we have noticed a control panel. This is the system called SR2000. Outside is the panel board. Here is where the surgeons would be seated. And the surgeons would be seated in front of the screens in order to have the manipulation, the control of the robotic arms. To the other end of this room, there are imaging machineries and some other installations. Later on, you can have a personal experience. I have some questions. What kind of surgeries are okay for this robotic arms? For example, for gynecology, and also for urology. So as an animator, I can have a personal experience. So this is a seat for the surgeons. And here we have to put on the 3D glasses. It's a product of a famous brand. And when you put on the glasses, you can immediately feel the clarity. And there are different screens. It can help you to have the fluorescent navigation, and we also have the side screens. You can use it for some note-taking and also for interaction. You can also see you're surrounded by different buttons by which you can rise this up, and you also have the pedals. You can use all those pedals and buttons to control the movement of the robotic arm. You can put your 2 fingers here and you click for once. And now we are controlling the robotic arm to pick up the rose petals. We can also regulate the distance from the robotic fingers and also the objects. And it's also a diversified product. It's very flexible fingers. It's more than 360 degrees. Actually, it's 270 to the right-hand side and 270 to the left-hand side. The two sides combined is 540 degrees. With this wide range of flexibility, we can help the surgeons to do the sewing up work and the other operations. So it's already applied in real practices. Yes, it's being commercialized. We have already installed 30 sets of these robots in the hospitals, and today with all the 30 sets of machines, we have completed more than 3,000 sessions of surgeries. In the future, we will continue to improve the precision level of the robotic arms, and we would like to bring up more capable machineries, robots, robotic arms to the users. And thank you very much. And this is a product made in China. And due to the time limit, I have to stop here. I think I can use two key sentences. First of all is the hardcore sciences application, and the other one is the enriched application of the robotic arms. Today we have witnessed many advanced products made in China, developed by China-based enterprises or China-based institute of researchers. Today we can use all those robotic arms to benefit the Chinese people to go to the underground environment to check out the mining and also to do the patrolling work. Today is the very first day of the 2024 World Robots Conference, and it will last for 5 days. It will close on the 25th of August, and I hope that you would continue to pay attention to this industry. That is all for our lives, for my part of the live streaming, and I would like to give the floor to my colleague.